Hello, my friend. Welcome to Can.Do.So. Today we're going to learn the ANOVA. And we're going to learn one-way ANOVA, two-way ANOVA, and repeated measures ANOVA. And first, let's note the three packages we are going to use in this lesson. The first one is tidyverse, and the second one is Palmer penguins, and the third one is Gapminder. First, let's take a look at the basic concepts. Uh, in the last test we have lesson we have learned the t-test, which is used to compare two groups, which could be two dependent samples or two independent samples. While ANOVA is used to compare three or more groups, which could be three or more dependent samples or three or more independent samples. So ANOVA, what is ANOVA? ANOVA is the short for analysis of variance. So it's a statistics method used for comparing means among three or more groups to determine if there are statistically significant difference between them. So ANOVA works by partitioning the total variance observed in a dataset into different components. The variance due to difference between groups and the variance due to differences within groups. And ANOVA will produces an F statistic, which compares the variance between group means to the variance within the groups. If the calculated F value is greater than the critical value from an F distribution table, it suggests that there are significant differences between at least two of the group means. So what is a one-way ANOVA? One-way ANOVA is used to compare the means of three or more independent or unrelated groups. In one-way ANOVA, we need to find F values, which is get by this. And this part, if you find it's difficult or not related to your target, you can skip it to the R part, R coding part. We don't need to calculate in this way, but we need to know the basic the background theory, background concept. So how we get there. So we can use a simple blood pressure data set to demonstrate the process we calculate the F statistics. We have the three groups: young, middle, and old. They have a different level of blood pressure. And first, we calculate the mean of each group. So let's go to the R. Okay, this is the data we have. And first we calculate the mean of each group. So we take data, this BP, take data and mutate the mean. So we got the mean young, mean middle, and mean old. We can change the location, young and mean young, middle and mean and old and mean old. So we use a select and we assign it to the BP, small BP. And second, we calculate the sum of squares of error, which is called SSE. So like this. First, we calculate this. And we calculate the sum of it mean yang, which means we use yang minus mean yang and squared and squared and middle minus mean middle and squared, we got this, and odd minus mean odd minus mean odd and squared, we got this. Then we summarize it, add this together, we got this. Okay, we got 60 and we save it to 60 to SSE. And third, we calculate the sum of squares between groups. So first we calculate the mean of the total mean. Total mean is the this 12 numbers. Calculate the mean, add together and take the mean, and we got this. And then we we distinct mean yang because here we have the same one, right? So we just need one. So we distinct it. Yeah, and we use it 4 times mean yang minus total mean. This one minus this one. And the square. Yeah, square. And summarize, we get SSP, which is 200. And now let's take a look at the degrees of freedom. Degree freedom of SSE is n minus k. N is a total number, it's 12, and k is group, 3 groups, so 12 minus 3 is 9. And degrees of SSB, it's k minus 1. K is a group number, so 3 minus 1 is 2. And then let's calculate the mean square between groups and the mean square of error. So we use SSB divided by degrees of freedom, and then we get 100, and SSE divided by its degrees of freedom, and it's 60 divided by 9. So now we can calculate the F value. F value is MSB divided by MSE. So yeah, it's 15. We can it's 15. So the F value is 15, which is greater than critical value. And if you find this is confusing, don't worry. Because we are learning R, so we have R to help us. So we use the original value gathered to the non-value, because this way the white value is not uh, uh, it's not ours typical type. So we want this type, and one group is one column is group, and the other column is blood pressure. So we use ANOVA, which is the function is AOV. We don't need to use other packages. This is basic. So in this, and we can use a summary. You can see that the p value is f value is 15, and p value is 0.00136, which is much smaller than 5%. So in this example, the p value is less than 5%. Therefore, we reject the null hypothesis and conclude that there is a significant difference in blood pressure among the three age groups. And we can check how different the means of the three groups are, because we only know there are groups. The three are not different, but which different? Maybe this one to this one is different, but this one to this one is the same, or maybe this one to this one is different, but this two is the same, so we can check it. We also have a R function, and this part is the same, and we use this TUK 2KHSD to check the difference. So we can say the old to middle difference, the p-value is 0.05, a little bigger than the 5% significant level. And young to middle is also a little significant, a little bigger than a significant level. But young to old is quite significant. And we can use the plot to show the difference. And we can see that the young and middle and old and middle is not very significant, but young and old is quite different, significant, because it's far from zero. And these two closely contains the zero. So we can see that the main difference is between the young and old groups. So just now we just used a very simple example to show how to calculate F value. Now let's use a real data set to do the same thing. And we use a Gapminder data set to compare the life expectancy of three different continents: Asia, Europe, and Americas. So in the t-test part, we compared two continents, but t-test cannot do the three continents. So here we use three continent and use ANOVA test. First, let's visualize the data. And we just take the 2007, and the continent is Asia, Europe, and Americas. And use ggplot2. X is continent is so three continents, and the Y is life expectancy. In this plot, we can see that Europe is quite different, but Asia and America is quite quite close. So we can use the test to we make our hypothesis is the mean life expectancy is the same across the three continents, or more accurate is not significantly different. And the mean, the null hypothesis is the mean life expectancy differs significantly, at least for one continent among the three. So we use R to do this. And py is quite small, close to 0. So we reject the null hypothesis and conclude that there is a significant difference. And which and how different, we can use a 2K HSD test. We can say that Asia and America is not significant, as we have concluded from the plot. But Europe to American and Europe and Asia are quite different, are very significant. Okay, that's one way. ANOVA. One way ANOVA is the three groups are independent because Asia, Europe, and America are independent. And now we use a two-way ANOVA. In two-way ANOVAs, we can use the penguins dataset. Two ways ANOVA, which means we only have one one factor which is continent, different continent. But if we want to use in this way, we want to compare the penguins' bill lengths. And in one way, we want to say if they're significant in different species. And we also want to say, so the second factor is the 6. If there's a significant difference among different gender. And also we want to say the interact species and 6. So we drop the NA values and get the box plot. So that's why we call this two-way. So in one way, we just compare this, compare the Atlantic chinstriped ginto, the three species. But in two-way, we not only compare the three species, we also compare the two genders. So that's what we will call the. So in this case, because it's a two-way, so it's a little complicated. Research question is we have different research questions. First, is there a significant difference in bill lengths across different species, like we said? And second, between do male and female penguins exhibit variations in bill? So the second is this. And is the third one, is there a statistically significant interaction effect between species and the 6 concerning bill lengths? Which means, is this one different to this one? Or this one different to this one? If this one to different this one? So there we have got, in each question, we got a hypothesis. And we use R to do this test. And we can see that species are quite significant. 6 are among them as quite significant. But species interaction with 6 is not significant. So because this is a total one, we can make it break down it to the So among species, which is all are significant, and among six, all are because there's only two, so there's only one comparison. But the interactions species against the six, we can say that. Oh, let me run it again to help it us. Yeah. We can easily find that only this one is not significant because it's 33% is quite greater than 5%. And this one is less than 5%, but bigger than 1%. And any others are close to zero. So we know that Can.Do female and chin strap female are quite significant different. So we can see that Can.Do female, Can.Do female, this one. And chin strap female, chin strap female, these two are quite different. Quite close. These two are quite close. Let me go back to this. Female, chin strap and Can.Do. Okay. Okay, these two are quite the same, and these two are quite the same. Male. Okay. Um, female is quite close, but the male is uh, not close. They are significant in 5% degrees. So this, but this looks more close to this one. I don't know. I don't know what's happened. In this case, this two looks a little different, and this two looks quite similar. So this should be male. Okay. Okay, don't worry. Okay, we can see the plot. And this one is Can.Do chin strip male. This one. And Can.Do female. And after that female. This one. Yeah, because there are too many, so it's not easy to make difference. Okay, now the last part, we go to the repeat measures ANOVA. Repeat measures ANOVA, it's like a paired ANOVA compared to paired t-test, because we compare the same group to their different stage or different conditions. For example, we want to test the patients after they take some pills, maybe half a year later and 1 year later, or even 2 years later, we can compare the different stages. But in t-test, we can only compare two stages, two conditions. So here we use Gapminder. We choose 3 years, and here we don't choose continents. So this is a more simple one. It's a one-way repeated measure all over. So we do this. We can see that they're quite different. So we test it. It's significant. Yes, based on the results, we can see that the p-value is close to 0, we reject the null hypothesis and conclude that there is a significant difference in life expectancy among the 3 years, 1952, 1982, and 2007. This quite is reasonable because there's almost 30 years uh, disparities. So the life expectancy should have improved. Okay, let's go back to the. So the ANOVA hypothesis test has assumptions that need to be made, including the normality, homogeneity, and independence. Normality, which means the dependent variable should be approximately normally distributed for each group of independent variable. Homogeneity of variances is the variance of the dependent variable should be approximately equal for each group of the independence variable. And independence, which means the observations should be independent of each other. Of course, this does not mean the repeated ANOVA. If we can use R to check the assumptions, if the assumptions meet or not. And if the assumptions are not met, we can use non-parametric tests such as the Krusakar-Wallis test to do the test. But since this is a beginner's course, so we don't cover that that part. But we just have the idea that there's some assumptions we need to make. If does not made, we need to change the test. Okay. So in this lesson, we learned one-way ANOVA, two-way ANOVA, and repeated measures ANOVA. Next lesson, we will learn how to do regression analysis in R. Okay, thank you. And please leave message and below to ask questions or offer me some suggestions. I will happy to answer your questions. And you can also go to my website to find the slides, and which is easy to find the code. You just copy the code, and you can go to your R to run it and to say if you get the same outcome. Okay, that's all. Thank you for watching. See you next time.